So the first thing we want to do is set up your equation. So we have iron, X, we don't know how much we have, oxygen, Y, so we don't know how much we have, plus CO, yields to CO2 plus iron. Now the gas law we're going to use is N equals PV over RT, where R is our constant of 0.0820057. Now our pressure was given to us in millimeters of mercury, so we have to convert that to atmospheric pressure. So we know per 1 atmospheric pressure equals 760 millimeters of mercury. So then we were given 751 millimeters of mercury. We throw the unit that we don't want on the bottom. 760 millimeters of mercury per 1 atmosphere. Get that. We plug that into our calculator. Get 0.98684 atmospheric pressure. Okay, now we're ready to plug that into our equation. So our pressure is 0.988 atmospheric pressures over, maybe all over, 0.082057. And then we were given 1.136 liters of CO2. And our temperature was 298 Kelvin. All right, put that into a calculator. I like to multiply straight across first in parentheses so that it gives me less margin of error. And the bottom one, which is 24.4509. That equals 0.0454 moles of CO2. Now to find our oxygen, we have to convert our moles of CO2 to grams. So we have to do another conversion. This is 0.0459 moles of CO2. And there is 15.99 grams. 1 mole of oxygen. That equals 0.734 grams of oxygen. Because I know that iron is our limited reagent and it's going to be used first, and then CO, oxygen. Now we were given 2.660 grams of oxide, and we're going to subtract our oxygen, 0.734 grams of oxygen. That equals 1.926 grams of iron. So that is our answer for part A. Now we're going to use our laws of definite proportion to find our empirical formula. So now we've got to convert our grams of iron back to moles. So we have 1.926 6 grams of iron. Our periodic table says we have 5.88 grams of iron for 1 mole. We plug that into our calculator and we get 0.03446 moles of iron. So we know that iron is 0.03446 plus oxygen, which is our 0 oxygen, and then 0.0459. Now we're going to divide by the smallest number, which is our iron, 0.03446, divide by 0.03446. We get iron is 1. Oxygen, however, is 1.33. Let's check that real quick. 0.0459 divided by 0.03446. Okay, so we're going to multiply everything by 3 to get a whole number. So that's iron, 3, oxygen, 1.33 times 3, 3.99, we're going to round up, which is 4. And here is our formula for part B. And we can plug this into this and then balance it to make sure, just to make sure we have the right answer. So it's iron, 3, oxygen, 4 plus CO yields CO2 plus iron. So we have 3 irons here, so we're going to put 3 here, so then that's our irons are balanced. And then we're going to, we have 4. Oops. So that's 4. Four carbons. And then 4 carbons. Now that that's balanced, we need to find how many irons and oxygens fit into our unit cell. We were given 839 picograms. We have to convert that. Convert. We know that from our unit conversions that picometers equals 10 to the negative 12. So let's convert. It's 839 picometers, 1 centimeter. There is 10, we have 10 centimeters. And that equals 839 times 10 to the 10 and 10 centimeters. Now, in order to get centimeters cubed, we're going to have to cube the entire to cube 800 to cube this right here. So that's gonna equal, so we do 839 times 10, 10 to 9 equals, okay, so that's gonna, our volume is 500.91 1 times 10 minus 22 cubic centimeters. So now we can plug that into our density formula. The density formula that we're going to use is M equals density times volume. So we know that our density, so M equals, you're given 5.20 grams cubic centimeters. I'm going to times that by our volume that we just found. So it's 5.91 times 10 to the 22nd cubic centimeters. I'm going to times that. So find our M. Which equals 3.07 times 10 to the negative 21st grams. Now, in order to find how many atoms of iron we have, we're going to use our mass, which is 3.07 times 10 to the 21st. And we're going to use the molar mass of 2.660 grams of Fe3O4, and that is 0.0344 moles of iron. And then for 1 mole of iron, we use Avogadro's number, onto the 23rd. That gives us iron 3 equals 23.96, which is 24. So there's 24 atoms of iron. And then we do the same thing to find oxygen. So again, we use our mass, 3.07 times 10 to the minus 21. And then we use 2.660 grams Fe3O4. And then we have oxygen, which was 0.059. Moles of oxygen. And then we have, for every 1 mole of oxygen, we use Avogadro's number again, 6.07 0.022 times 10 to the 23rd. Plug that in. So oxygen equals 1.90, which is 32 atoms of oxygen.